Question 5. Consider the following directed line segment, segment BA. What are the coordinates of the point that partitions segment BA according to the part-to-part ratio of 2 to 3? So since this is a directed line segment, I know that segment B is where I start, segment A is where I end because segment A has the arrow. So we are going to be labeling this. This is from point B to point A in the part-to-part ratio. So the first thing that I do is first, since it's giving me a graph, I like to use the tools that I know to find the coordinates for the point that partitions this segment BA using the graph. You do not always have to use a formula. If you understand a different way, then use that method. So I understand it with a graph and I understand what's going on with it. So the first thing that I do is I find out that the part-to-part ratio is 2 to 3. That means that I have 2 segments before the point, right, say the point ended up being right here, and then I would have 3 segments after that point. So when I convert this to a part-to-whole ratio, how many total segments would I have? I would have 5 total segments. I would have 2 from point B to the point and 3 after the point to point A. So I have a total of 5 segments. And now I'm going to start from point B because that's what the starting point. So from the starting point to the point, there's going to be 2 segments. That's showing up right here as that 2. So we have 2 segments to the 5. So I'm going to convert it to a fraction, which would be 2/5. So now I'm going to find the vertical distance from point B to point A, which is 1, 2, 3, 4, 5. So it's a total of 5 vertical units. And now I know that if I only want to have 2 segments before that point, I'm going to take this distance and multiply it by the fraction that we just had. 2/5 is our part-to-whole fraction times, so I only want 2/5 of my vertical distance, 2/5 times 5, and if we multiply that out, that reduces down to 2. And then horizontally, how many? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 units. And again, we want to find a point that's 2/5 of that distance, 2/5 of our 10 horizontal distances. So if we were to multiply that out and reduce, that would come out to be 4. So I know that this point that is 2/5 of the way up, this segment is going to be up 2 units. So it's going to be up 2 units. And it's going to be over 4 units. 1, 2, 3, 4. So at these intersections of the vertical line and the horizontal line on our directed line segment, that is going to be the coordinates for that point that would partition it into 2 segments, 1, 2, compared to a total of 5 segments. You know, there'd be 1, 2, 3 more afterwards. So there would be a total of 5 segments. So this is 2/5 of our distance down this directed line segment. So our coordinates would be -2, 3. So -2, 3.